Welcome to the Public Exam Review for Unit 3, Chapter 2 on Radical Functions. In this presentation, we will look at the square root of linear functions of the form y equals the square root of ax plus b. Here we will focus on sketching the graph of y equals the square root of f of x, given the graph of y equals f of x as a linear function. We will explain strategies for graphing y equals the square root of f of x, given the graph of y equals f of x. And we will compare the domains and ranges of the functions y equals f of x and y equals the square root of f of x, explaining any differences. To begin, if f of x is equal to x minus 1, then sketch the graphs of y equals f of x and y equals the square root of f of x on the same coordinate plane. If we look at the equation, f of x is equal to x minus 1, we should recognize it as a linear function, where the slope of the function is equal to 1, and the coordinates of the y-intercept are at 0, negative 1. To begin to sketch the graph, we start at the y-intercept, and a slope of 1 means we have a rise of 1 and a run of 1. A rise of 1 and a run of 1. We can connect these points using a straight line. Just let me move the line so that it fits properly. And this is the graph of y equals f of x. Let's take some points on this graph to determine the coordinates of points on the square root of that function. So the first point that we have here, we will use 0 and negative 1. Note that the value of f of x is a negative 1, so the square root of a negative 1 is not defined, because you cannot take the square root of a negative number using the real number system. The next point we will choose is at 1 and 0. The square root of 0 is 0. Then we have the point 2 and 1. The square root of 1 is at 1. And another point that we will appropriately choose will be when x is equal to 5, the y value is equal to 4, and the square root of 4 is equal to 2. Using these points for the square root function, we can now plot the point 1, 0 on the square root graph, the point 2 and 1, and the point 5 and 2. Connecting these points, note that between 0, when y is equal to 0 and when y is equal to 1, that the graph of the square root function is greater than the graph of the original function. Expanding the graph, we have the graph of y equals the square root of f of x. The domain of the square root function is all values of x that are greater than or equal to 1. And x belongs to the set of real numbers. The range, on the other hand, are all values of y that are greater than or equal to 0, and y belongs to the set of real numbers. Note that when you're working with these functions and their square roots, that when y is less than 1 but greater than 0, note that the square root of the function will always be greater than the original function, than the graph of the original function. That's an important point to remember. So if the square root function is greater than the original function, between y equals 0 and y equals 1, the square root graph will be above the original function. Invariant points, on the other hand, are points that are common to both graphs. So if you look at the functions that are graphed here, you can see that one invariant point occurs at 1 and 0, and the other invariant point here occurs at 2 and 1. Invariant points will always occur when y is equal to 0 and when y is equal to 1, because it's at these 2 points that the original function will be equal to that of the square root function. Notice there that the y values are equal at 0 and at 1. So the invariant points for this example are at 1, 0, and 2 and 1. In the next example, we are asked to sketch the graphs of y equals f of x and y equals the square root of f of x on the same coordinate plane, given that f of x is equal to a negative a half x plus 4. This will represent the graph of a linear function with a negative slope. Therefore, the straight line will slant upward to the left. So here we have f of x is equal to a negative a half x plus 4. Again, it represents a linear function in which the graph is a straight line, the slope is a negative 1 over 2, and the coordinates of the y-intercept are at 0 and 4. Beginning at the y-intercept, 0 and 4, we will go down 1 to the right 2, down 1 to the right 2, and we will get the graph of another linear function. Connecting these points, we have a straight line. Let me maneuver this graph a little bit. So there's the straight line, the graph of y equals f of x. In order to graph the square root function, let's look at some key points on the original function. If we look at when x is equal to 0, the coordinate for y is at 4. The square root of 4 is equal to 2. So we have the point 0 and 2 on the graph of the square root function. Then we can look at the point where x is equal to 2. When x is equal to 2, the graph, the y value corresponds with 3, and the square root function will be the square root of 3, which is a decimal approximation, which is why it's not an overly important point to have chosen, because the square root of 3 is approximately 1.73. So we have to estimate where that's at on the graph. So the point 2 and 1.73 is approximately right here. Next, we will choose the point where x is equal to 4. When x is equal to 4, we have the value of y to equal 2. So the square root graph would be the square root of 2, which is approximately 1.41. Again, we have to estimate where that graph is located. When you have the point 6, when x is 6, the value of y is equal to 1, and the square root of 1 is 1. So the coordinates of the point 6 and 1 will also be on the new graph. And as well, when x is equal to 8, we have the y-coordinate to be 0, and the square root of 0 is 0. So the coordinates 8 and 0 will also be on the new function, the graph of the square root function. Connecting these points, again, remember that between y equals 0 and when y is equal to 1, we have the graph of the square root function will be above or greater than the graph of the original function. So to sketch the graph of the square root function looks something like this. That represents the graph of y equals the square root of f of x. In stating the domain, note that it includes all values of x that are less than or equal to 8, and x belongs to the set of real numbers. And the values of the range include all values of y that are greater than or equal to 0, and y belongs to the set of real numbers. Your invariant points will always occur when y is equal to 0 and when y equals 1. Notice that these points are common to both graphs. So in this case, your invariant points occur at 8 and 0 and at 6 and 1. Which represents the graph of y equals the square root of f of x? In order to determine the answer to this question, I recommend that you look at the coordinates of the invariant points to begin. So when y is equal to 0, we have x to equal a negative 2. When y is equal to 1, the corresponding graph would equal a -4. So because the square root function is greater than the graph of the original function, it will be above that straight line for this region. So the graph of your square root function looks like similar to this, and that corresponds with B as your multiple choice answer. Note that the endpoint of your square root function begins there at -2, and it will slant towards the left side. So that's the graph of your square root function. In another example, we are asked, what are the invariant points for the function f of x equals 3x minus 1 and f of x equals the square root of 3x minus 1? The key words here are invariant points. Note that the invariant points will occur when f of x is equal to 0 and when f of x is equal to 1. Therefore, we have 3x minus 1 is equal to 0, where 3x is equal to 1, and x is equal to 1/3. So one invariant point will occur at 1/3 and 0. The other invariant point will occur when 3x minus 1 is equal to 1, 3x is equal to 1 plus 1, 3x is equal to 2, and x is equal to 2/3. So the other invariant point occurs at 2/3 and 1. This answer corresponds with B as your multiple choice answer. In example 3, if f of x is equal to x minus 4, which point is contained on the graph of y equals the square root of f of x? In this example, I recommend that you set up a table of values. In one column, we'll record the values of x, and notice that in the points that are listed as multiple choice possibilities, the coordinates of x can either be -4 or a +4. So we'll choose x to be a -4 and a +4. When we evaluate what f of x is, we substitute a -4 into the original function to determine the value of y. So when x is a -4, y will equal a -4 minus 4, which is a -8. When you take the square root of a -8, you know that that value is undefined because we cannot take the square root of a negative number using the real number system. So the square root of a -8 is not defined. When we substitute the value of x equals 4, we have 4 minus 4, so f of x is equal to 0. And the square root of 0 is 0. The coordinates of the point on the graph of the square root function is C, 4 and 0. In example 4, given the graph of y equals the square root of f of x, what is the equation of f of x, the original function? In order to answer this question, I recommend that you, again, go to your invariant points. The invariant points occur when y is equal to 0 and when y is equal to 1. So the first invariant point that you have is at -9 and 0. The other invariant point that you have is at -8 and 1. If you know the coordinates of any 2 points that lie on a line, you could connect those points and you would indeed get the graph of a straight line. So we can determine the equation of that line, which will give us the equation of f of x. Using 2 points, we can determine the slope using the slope formula, where you have the difference in your y's over the difference in your x's. So the slope in this case would be given by 1 minus 0 all over a -8 minus a -9. That equals 1 divided by a -8 plus 9, which is 1. So the slope of this function is equal to 1. So we have y equals 1x plus b. in order to determine the coordinate or the value of b, we have to pick a coordinate that lies on the graph. So let's choose the point -9 and 0 and substitute those coordinates in for x and y into the equation to determine the value of b. So we have y is equal to 0, x is equal to a -9 plus b. Bring the 9 to the left-hand side, so we get 9 is equal to b, and then the equation of this linear function is given to be f of x equals x plus 9. And that answer corresponds with D as your multiple choice answer. In example 5, we are asked to use the graph of f of x to answer the questions that follow. First of all, we have to state the invariant points that would be contained on the graph of y equals the square root of f of x. Again, let's look at where the value of y is equal to 0. So y is equal to 0 when x is equal to a -8. So one invariant point would be at -8 and 0. And the other invariant point will occur when y is equal to 1. So the value of x for which y is equal to 1 is a positive 6. I'm sorry, I said that the original point was at -8 and 0, and I meant to say that it was at 8 and 0. It's on the positive x-axis, so it should be at 8 and 0. And the other invariant point occurs when x is equal to 6, so the other invariant point is at 6 and 1. Now we're asked to explain why the domain of y equals the square root of f of x is x such that x is less than or equal to 8 and x belongs to the set of real numbers. In the case f of x, in order to find the square root of anything, the square root of f of x has to be greater than or equal to 0. In other words, it is not defined when f of x is less than 0. So it's not defined, or I should rephrase that. Y equals the square root of f of x is not defined when f of x is less than 0. That would be the region below the x-axis. That's the region below the x-axis. So the square root function is not defined for any value of x that is greater than 8. So in this case here, we have the value of f of x. F of x is greater than or equal to 0 when x is less than or equal to 8. So that's why the domain of the function is x such that x is less than or equal to 8. Now we're asked to construct the graph of y equals the square root of x, clearly indicating the invariant points and at least 3 other points on the graph. So here we have, and we can use a table of values to illustrate this if you like. So we can set up a table of values. In one column, we'll record x. Another column will record f of x. And in the third column, we can look at the square root of f of x. So to include the invariant points, when x is 8, f of x is 0, and the square root of 0 is 0. Then we can look when x is equal to 6, f of x will equal 1, and the square root of 1 is 1. Another invariant point will occur when an appropriate one to choose could be when x is equal to 0. F of x is equal to 4, and we know that the square root of 4 is equal to 2. So that would give us another point on the square root function graph. Another value, we can find the next appropriate value, like you could, when you're trying to determine that value of x. When f of x is equal to 9, you know that the square root of 9 is equal to 3. So you have to go to where y is equal to 9 on your graph, which is over here at this point, and the corresponding x value would be at -10. So when x is a -10, the value of y on the square root function graph will be at a positive 3. So this will give you the graph of the square root function. That's the graph of y equals the square root of f of x. You could have also used the point, for example, where x was equal to 5. When x is equal to 5, the value of y, you have to estimate where that's at, don't you? So it was probably better for us to have taken x equals 4. When x is equal to 4, you can see there that the graph passes through y equals 2. So then the corresponding value on the square root function would be the square root of 2, which is approximately 1.4. So in that case, it's not a clear-cut point, but you would have to estimate that that point is at 1.4, which is the square root of 2. As a summary then, you can use values of f of x to predict values of the square root of f of x and to sketch the graph of y equals the square root of f of x. The key values to consider are when f of x is equal to 0 and when f of x is equal to 1. These will provide us with the invariant points of your square root function and the original function. So they do provide us with the coordinates for the invariant points. The domain of y equals the square root of f of x consists of all values in the domain of f of x for which f of x is greater than or equal to 0. F of x cannot be less than 0 because that would result in taking the square root of a negative number which is not defined using the real number system. The range of y equals the square root of f of x consists of the square roots of all values in the range of f of x for which f of x is defined. The y-coordinates of the points on the graph of y equals the square root of f of x are the square roots of the y-coordinates of the corresponding points on the original function y equals f of x. The relative locations of y equals f of x and y equals the square root of f of x. If f of x is less than 0, then the graph of y equals the square root of that is undefined. Again, because it would result in taking the square root of a negative number which is not defined using the real number system. When f of x is equal to 0, the graphs of y equals the square root of f of x and y equals f of x intersect on the x-axis. That would provide us with a coordinate for the invariant point. When f of x is between 0 and 1, note that the graph of the square root function is above the graph of y equals f of x, the original function. That's an important statement when you're sketching the graph. So between 0 and 1, the graph of y equals the square root function is above the graph of the original function. Then you have when f of x is equal to 1, that's where the graph of the square root function intersects the graph of the original function, which again provides us with the coordinates of another invariant point. And finally, when f of x is greater than 1, the graph of the square root function is below the graph of the original function. If you have any questions related to any of this content, please pose your question in the question forum and we will attempt to answer it for you. Thank you for your time and your attention.